I will start the redox reactions question answer discussions. Question number 1. In the following reaction, 3Br2 plus CO3 2 minus plus H2O gives 5Br minus plus BrO3 minus plus HCO3 minus. Now we have to identify the correct option for this reaction. Bromine is oxidized and carbonate is reduced. Second option, bromine is reduced and water is oxidized. Third option, bromine is neither reduced nor oxidized. Fourth option, bromine is both reduced and oxidized. First, observe the oxidation state of each and every atom shown in the reaction. The reaction given is 3Br2 plus 6CO3 2 minus gives 5Br minus plus BrO3 minus plus 6HCO3 minus. This is the reaction given in the problem. Now we have to identify which atom is undergoing oxidation and which atom is undergoing reduction. For that purpose, you observe the oxidation state of every atom. Here on the reactant side, bromine has oxidation state 0. On the product side, here bromine is exhibiting the -1 oxidation state. Here bromine is exhibiting the +5 oxidation state. That means some bromine atoms they are undergoing reduction. Next, some bromine atoms they are undergoing oxidation. Here these bromine atoms they have undergone oxidized. Here they have undergone reduced. Next, here you observe similarly observe the oxidation state of the carbon here. Here oxidation state of the carbon here is a +4, here also +4. Next, the oxidation state of the oxygen here is -2, here also -2. Therefore, in this entire reaction for only bromium there is a change in the oxidation state. Some bromine atoms are undergoing reduction, some are undergoing oxidation. So, the correct option is the bromine is reduced, the bromine is both reduced and oxidized. Answer is 4. Okay, sir. Second question number 1. Wait. Next, question number 2. So, in the following reaction, 4P plus KOH plus 3H2O gives 3KH2PO2 plus PH3. For this question, the options given are P is oxidized as well as reduced. P is reduced only. P is oxidized only. None of these. Now, let me represent the total reaction. 4P plus 3KOH plus 3H2O gives 3KH2PO2 plus PH3. So, in this reaction we have to identify which atom is undergoing oxidation and which atom is undergoing reduction. So, now identify the oxidation state of every atom. For phosphorus, here the oxidation state is 0. Here the oxidation state is -3. Here the oxidation state is +1. That means the phosphorus atoms which are coming into this compound they are undergoing oxidation. The phosphorus atoms which are coming into this compound they are undergoing reduction. That means phosphorus atoms are undergoing both oxidation and reduction. Similarly, for potassium you observe the change in oxidation state. Here +1, here +1. There is no change in the oxidation state of the potassium. Similarly, for oxygen, here -2, here also -2. For oxygen also there is no change in the oxidation state. For hydrogens also there is no change in the oxidation state. Therefore, in this entire reaction only for phosphorus there is change in the oxidation state. Therefore, some phosphorus atoms are undergoing oxidation, some are undergoing reduction. Hence, the answer is 1. Yes, sir. Next, question number 3. Identify the question number 3. Identify the correct statement about the hydrogen peroxide. It acts as reducing agent only. It acts as both oxidizing and reducing agent. It is neither oxidizer nor reducer. It acts as oxidizing agent only. So, among these 4 options, now we have to identify the correct option that is applicable to the hydrogen peroxide. First, you observe the oxidation state of the oxygen in hydrogen peroxide. For oxygen, the oxidation state is -1. Now, if you observe the oxidation states of the oxygen here, oxygen, so since it has 6 valence electrons, the maximum oxidation state that can exhibit by the oxygen is +6, and the least possible oxidation state for oxygen is -2. So, for oxygen, the maximum possible oxidation state is +6, least possible oxidation state is -2. Therefore, in general, if any atom exhibits one of its intermediate oxidation states, that means that if that oxidation state is neither equal to highest possible value nor equal to minus, that means least possible value, therefore, in that compound, that particular element always act as both oxidizing and reducing. Oxidizing and reducing. So, not only in this example, in any other example, if any one atom exhibits the one of the intermediate oxidation states between highest value and least value, then entire compound will act as the oxidizing and reducing agent. Therefore, answer is 2. Next, question number 4. Several blocks of the magnesium are fixed to the bottom of the ship to, first option, to keep the sharks away. Second option, make the ship lighter. Third option, prevent action of water and salt. Fourth one, prevent puncturing by undersea rocks. So, here the purpose of hanging magnesium to the ship is here. Ship is usually made out of the iron and some other alloys. Here these are the magnesium blocks. So, we know magnesium belongs to the S block element. So, in general, S block elements, they will easily undergo oxidation. Therefore, when ship is moving in the sea, these magnesium atoms, they will undergo oxidation and they release their electrons to the iron. Therefore, they act as the electron suppliers to the iron. Thus, they will prevent the oxidation of the iron, or in other words, they will protect the iron and some other elements present used in the construction of the iron. Hence, the option is 3. That means magnesium will act as the protector. By sacrificial under oxidation, it will protect the iron. Therefore, it will prevent the action of water and salt on the ship. Yes, sir? Next, question number 5. Which of the following is most powerful oxidizing agent? 1. Fluorine, 2. Chlorine, 3. Bromine, 4. Iodine. So, in this entire periodic table, if you observe the electronegativities, fluorine has the highest possible electronegativity. Therefore, fluorine has the highest ability to gain electrons. Hence, any element which has highest ability to gain electrons will always act as the most powerful oxidizing agent. Therefore, answer is 1. Answer is 1. Next, question number 6. Which of the following substances act as the oxidizing as well as reducing agent? First option sodium oxide, second option SnCl2, third option sodium peroxide, fourth option NaNO2. So, which of the following will act as the both oxidizing as well as reducing agent? Now, observe the all four options. Here in the first option they have given the Na2O. So, in the first option sodium, again when once the sodium is in the +1 oxidation state, it neither gains the electrons nor loses the electrons. Here oxygen is already in the -2 oxidation state. So, when it is in the -2 oxidation state, it can at the most it can supply its own electrons. Again it can't gain the electrons. That means it can act as the reducing agent. Therefore, it cannot act as both oxidizing and reducing. Similarly, SnCl2. In SnCl2, this stannum is in +2 oxidation state. Therefore, by supplying 2 more electrons, it can go to the +4 oxidation state. That means SnCl2 will always act as the electron supplier or reducing agent. Therefore, it won't act as both oxidizing and reducing. Similarly, sodium peroxide. Here sodium peroxide is given. Here in this sodium peroxide, sodium again do not undergo either oxidation or reduction. Only the peroxide ion can undergo oxidation. This peroxide ion, it can act as the electron supplier only. It can act as the electron supplier. Therefore, again it won't act in both the ways. Next, in the fourth option, they have given NaNO2. Here in this NaNO2, nitrogen is in the +4 oxidation state. Therefore, either it can go to +5 oxidation state or it can go to +2 or +3 oxidation state. Since nitrogen is in one of the intermediate oxidation states, therefore, it can either act as the oxidizing agent or it can act as the reducing agent. Hence, option is 4. Okay, sir. Okay, sir. And next, question number 7. In which of the following compounds the transition metal has a 0 oxidation state? In the first option, CrO5 is given. Here chromium exhibits the, here CrO5, it has the butterfly structure. Therefore, in this butterfly structure, chromium exhibits the +6 oxidation state. In the second option, they have given the NH2, NH2. Here nitrogen, this nitrogen exhibits -2 oxidation state, this nitrogen exhibits the -2 oxidation state. Next, NOClO4. Here the Cl is in the +7 oxidation state. Next, fourth option, FeCO 5 times. Here in this fourth option, the FeCO5 is given. Iron is a transition element, its oxidation state is 0. Therefore, answer is 4. Next, question number 8. The oxidation number of the carbon in CH2Cl2. In CH2Cl2, if you observe the structure of the CH2Cl2, We know chlorine is more electronegative than carbon. Therefore, here chlorine will gain 1 electron. Here this chlorine will gain 1 electron. Next here, therefore, due to these two bonds, carbon loses 2 electrons. Next hydrogen. So here hydrogen oxidation state is +1. Here oxidation state is +1. Therefore, due to these two bonds, carbon will gain the 2 electrons. Therefore, the net change in the oxidation state of the carbon is 0. Therefore, answer is 1. Next, question number 9. The oxidation state of the chromium in, they are given the chromium ammonia complex. This is the complex given in the problem. Now we have to determine the oxidation state of the chromium in this complex. Here, let us assume the oxidation state of the chromium is let us say X. And next, NH3 is a neutral ligand. So 4 neutral ligands are present. Therefore, oxidation states of the ammonia is 0. Next, chlorine -1. So 2 chlorine atoms are there. So -2. Sum of the oxidation states of all species shown in the coordination sphere is equal to the charge shown over the coordination sphere. Therefore, X is equal to +1. Here +2. Therefore, +3. +3. So, answer is 1. Next, question number 10. The oxidation state of the iodine in the given molecule. The molecule given here is H4IO6 minus. In this molecule, we want to find out the oxidation state of the iodine. So let us say the oxidation state of the iodine is let us say X. We know the oxidation state of each hydrogen is +1. Therefore, here 4 hydrogen atoms are there, +4. Next, we know oxidation state of each oxygen is -2. Therefore, it is -12 is equal to -1. Therefore, X is equal to -1. Here +5 +4 is sent that side. So, it becomes -4 plus 12. Therefore, answer is -5 plus 12. Therefore, +7. So, answer is 1. So, next. Yes. Next, question number 11. In which of the following compounds the oxidation state of the carbon is maximum? In the first option, they are given the HCHO. Here HCHO means actually this is a formaldehyde. In the first option, this is the compound given. Here in this compound, the oxidation state of the carbon will become 0. Here because due to this double bond, carbon loses 2 electrons. Due to these 2 hydrogens, it will gain 2 electrons. Therefore, net change in the oxidation state of the carbon is 0. Next, in the second option, they are given the CHCl3. So, in this CHCl3, again if you observe the structure, here this is the structure of the compound. Here due to these 3 bonds, carbon loses 3 electrons, hence it gets the +3 oxidation state. Due to this hydrogen, it will gain 1 electron. Therefore, net change in the oxidation state of the carbon is +2. Next, in the third option, CH3OH is given. If you observe the structure of this CH3OH, here due to these 3 hydrogens, the carbon will gain 3 electrons. Due to this oxygen, it will lose 1 electron. Therefore, the net change in the oxidation state is -2. Next, in the last option, they are given the C12H22O11. In this sucrose, if we calculate the oxidation state of the carbon, we will get the 0. Now, we have to identify the option in which the oxidation state of the carbon is maximum. Here 0, here 0. Therefore, first option and last option wrong. Next, in the second option +2, in the third option -2. Therefore, second option is the correct. So, answer is 2. Next, the question number 12. The value of x in the partial redox equation. The redox equation given is MnO4 minus plus 8H plus x electrons gives Mn2 plus 4H2O. So, in this partial redox reaction, we have to identify the number of electrons participating. Here, first observe the oxidation state of the manganese. Here +7, here +2. Therefore, in this reaction, one manganese atom is actually gaining the 5 electrons. Therefore, X must be 5. Therefore, answer is 1. Answer is 1. Next, in the given reaction C2H6, next question number 13. In the given reaction, that reaction is C2H6 in the gaseous state. It is reacting with the oxygen. Here CO2 plus H2O. CO2 plus H2O. In this reaction, the ratio of the coefficients of the CO2 and H2O have to be identified. See here, when we take 1 mole of the C2H6, 1 mole has 2 carbons. Therefore, on the product side also, the CO2 should be 2 moles. Next, 1 mole has the 6 moles of hydrogen atoms. Therefore, on the product side, we have to show 6 moles of the hydrogen atoms. Therefore, put 3 here. Next, now adjust the coefficient of the oxygen. Here 4 oxygen atoms, here 3 oxygen atoms, total 7. Therefore, 7 oxygen atoms we have to show here. This here 4 plus 3 7. So, therefore, here 7/2 O2. Therefore, the mole ratio of the CO2 and H2O is 2:3. 2:3 is given in the second option. Next. Question number 14. How many moles of the K2Cr2O7 can be reduced by 1 mole of SN2 plus? See, K2Cr2O7, in any reaction, if 1 mole of K2Cr2O7 participates, 1 mole of K2Cr2O7 always gains 6 moles of electrons. Similarly, SN2 plus, when 1 mole of SN2 plus participates, 1 mole of SN2 plus always supplies 3 moles of electrons. Hence, SN2 plus will always get converted into SN plus 4. So, it will supply 2 electrons. Here, each chromium will be converted into +3 oxidation state. If you take 2 moles of the K2Cr2O7, here 2 moles of the chromic ions will be produced. Therefore, 1 mole of the K2Cr2O7, how many moles of K2Cr2O7 can be reduced by this 1 mole of SN2 plus. Here, say according to this reaction, first you equalize the number of electrons that are being exchanged. See here 1 mole of K2Cr2O7 requires 6 moles of electrons. But here 1 mole of Sn2 plus supplies only 2 electrons. Therefore, in order to adjust the electrons that are being exchanged, here put 3 here. If you take 3 moles of Sn2 plus, 3 moles will supply 6 electrons. All those 6 electrons will be absorbed by 1 mole of K2Cr2O7. Now, so this is the balanced equation with respect to number of electrons exchanged. Now, in this reaction, you see 3 moles of Sn2 plus is reducing 1 mole. Next, 1 mole can reduce how many? 1 by 3. Therefore, 1 mole of Sn2 plus can reduce 1/3 of the mole of the K2Cr2O7. Hence, answer is 1. Next. Next, question number 15. Here MnO4 permanganate, it is participating in the reaction. They have taken 2 moles of the permanganate. It is reacting with the 5 moles of the H2O2, 5 moles of H2O2 plus 6 moles of H plus. Gives here they have given 2Z plus 8 H2O. This is the reaction given. In this reaction, we have to identify this Z. See, in general, when permanganate participates in any reaction in acidic medium, 1 mole of the permanganate always gains 5 moles of electrons. Therefore, this permanganate always get converted into Mn2 plus. Therefore, definitely Z must be Mn2 plus. Therefore, identify the option where Mn2 plus is shown. That is shown only in the option 1. Next, question number 16. What is A in the following reaction? The reaction given is 2Fe 3 plus in aqueous medium. Next, Sn2 plus in aqueous medium gives this is. See here, this ferric has undergone reduction into ferrous. Therefore, this is a reduction reaction. Next, Sn2 plus stannous. When ferric undergoes reduction, this is stannous. It must be definitely undergo oxidation. Therefore, when stannous undergoes oxidation, it will produce the stannic. Hence, that stannic must be definitely Sn4 plus. So, identify this option where Sn4 plus is shown. That is shown in option 2. Option 2 is correct. Next, for the given redox reaction, next question number 17. For the given redox reaction, we have to identify the stoichiometric coefficients shown in the options. So, first let me represent the reaction. MnO4 minus plus C2O4 2 minus plus H plus. Here Mn2 plus plus CO2 plus H2. So, first when any redox reaction is given, in order to balance the reaction, first identify the atoms whose oxidation state is changing. Here in this reaction, for manganese there is change in the oxidation state. Here before the reaction, the oxidation state of manganese is +5. After the reaction, the oxidation state of manganese is +2. So, for manganese there is a change in the oxidation state. That change, due to that change, we can say manganese is undergoing reduction. Similarly, identify the other atom whose oxidation state is changing. In this reaction, for carbon also there is change in the oxidation state. Before reaction, the oxidation state of the carbon is +3. After the reaction, the oxidation state of carbon is +4. Now, therefore, for manganese there is change in the oxidation state. For carbon also there is change in the oxidation state. Therefore, the first step is always identification of the atoms whose oxidation state is changing. Next, after identifying, the second step is always balance the atoms whose oxidation state is changing. See, for manganese there is change in the oxidation state. Now you balance the manganese atoms. You see, already they are balanced. Next, for carbon also you balance the atoms. Now here on the reactant side 2 carbons are existing, here only 1 carbon. Therefore, by adjusting the stoichiometric coefficients, you balance the carbon atoms. Now carbon atoms are also balanced. So first step is the balancing of the atoms whose oxidation state is changing. So now we have balanced. After balancing, now observe the total charge difference for first species and for second species. For manganese, total oxidation state on the reactant side is +5, here +2. So therefore, what is the total difference? Here here +7, here +7, +2. Therefore, total difference is 5. Next, for carbon, what is the total oxidation state? +3, +3. Total oxidation state is +6 here. Here total oxidation state is +4 and +4. Therefore, +8. Difference is 2. So after identifying the difference in the total charge of the first species and second species, exchange these differences, then adjust the stoichiometric coefficients. So therefore, you keep this 5 here, you keep this 2 here. 2MnO4 minus. If you keep 5 here, it becomes 5C2O4 2 minus plus H plus gives 2Mn2 plus 10CO2 plus H2. So we have adjusted the ratios. Next, now count the oxygens here. Here 8 oxygens here, here 20 oxygens. Total 28 oxygens are existing here. Here total 20. Therefore, now identify the side where deficiency of oxygen is existing. Here total 28, here total 20. That means here 8 oxygen atoms are less. So for each oxygen, you add 1 water molecule. Therefore, here you put the 8. If you put the 8, oxygen atoms will get balanced. Even in order to balance the oxygen atoms, we have added the water molecules. When water molecules are added, definitely the hydrogen atoms will get change. Therefore, now adjust the hydrogen atoms. If the reaction is taking place in acidic medium, for each hydrogen atom, you add the 1 H plus. Here now you see 16 hydrogen atoms are present. Therefore, this side we need 16. Therefore, put 16 here. Therefore, now for MnO4 2 minus, the stoichiometric coefficient is 2. For 5, the oxalate stoichiometric coefficient is 5. For H plus ions, stoichiometric coefficient is 16. Therefore, the stoichiometric coefficients are 2, 5, 16. Now identify the option where these 2, 5, 16 are shown. In the first option only, these 3 values are shown. Therefore, answer is 1. Next. Next. In the given balanced equation, we have to identify the stoichiometric coefficients. So therefore, first, question number 18. Question number 18. In the balanced equation, we have to identify the stoichiometric coefficients. So the equation given in the problem is IO3 minus plus AI minus plus BH plus gives CH2O plus Di2. So now we have to identify this value of A, value of B and value of C. For this purpose, now identify the change in the oxidation state of the various atoms. Here oxidation state of the iodine is +5, here iodine is -1. This side the oxidation state of every iodine is shown as 0. Therefore, here 2 iodine atoms are present, here 2 iodine atoms are present. Now adjust that number of electrons that are being exchanged between the iodine atoms. Here this iodine is in +5 oxidation state, this iodine is in -1 oxidation state, but here each iodine is in 0 oxidation state. That means if you observe the change in oxidation state, we can say this iodine atom, it is gaining how many electrons? See, it is moving from +5 to 0, no? So it is gaining 5 electrons. This iodine is gaining 5 electrons. From where it is gaining? From the other iodine atoms. Here what is the oxidation state of the iodine? Here -1, here 0. That means each iodine, it is releasing 1 electron, but this iodine requires 5 electrons. Therefore, for 1 mole of the IO3 minus, you take 5 moles of I minus, 5 I3 I minus. Therefore, 1 plus 5. So, therefore, total 6. Therefore, it should be 3. Next, after adjusting the species which are undergoing exchange of electrons, then balance the oxygens. Here 3 oxygens are present, this side only 1. In all reactions, for each oxygen, always add 1 water molecule. If you put 3, the total number of oxygen atoms becomes 3. They will get balanced. Next, the reaction is taking place in the acidic medium. Therefore, the balance the hydrogen atoms by adding H plus ions. Here 6 hydrogens are shown, here only 1 H plus. That means this side we need 6 H plus ions. Put 6 here. Therefore, A will be definitely 5. Next B must be 6. Next C must be 3. Next D must be 3. So, A, B, C, D values are 5, 6, 3, 3. Now, therefore, identify the option where 5, 6, 3, 3 are shown. So, answer is 1. Next, question number 19. Which of the following is the strongest oxidizing agent? Here in all these 4 options, they have shown different species along with the electrode potentials. So, first observe the electrode potentials. Based on the electrode potentials, now we have to identify the most strongest oxidizing agent. See, in the first option, they have shown BrO3 oblique Br2 plus. Next, here oxidation, the reduction potential given is 1.5 volts. Next, Fe3 plus, Fe2 plus. Here reduction potential is 0.76 volts. Next, MnO4 minus, Mn2 plus. Here reduction potential here is 1.52. Next, Cr2O72 minus gives Cr3 plus. E0 is 1.33 volts. So, these are the 4 different species that are given along with the reduction potential values. Now, based on reduction potential values, we have to identify the most powerful oxidizing agent. If any species wants to act as the oxidizing agent, its reduction potential must be more than the other species with which it is reacting. That is one point. Next, second point is, among the given species, relatively if you want to select the most powerful oxidizing agent, just compare the reduction potential values. Any species whose reduction potential is highest among the given 4 species, that will act as the most powerful oxidizing agent. In this question, in the third option, For MnO4 minus 2 Mn2 plus, the reduction potential given is very highest, hence it is the most powerful oxidizing agent, hence answer is 3. Next, question number 20. For decolorization of 1 mole of the KMnO4, the moles of H2O2 required. See, KMnO4, it is reacting with the H2O2. If the reaction takes place in acidic medium, this KMnO4, it will be converted into Mn2 plus. Mn2 plus. Next, H2O2, it will be converted into H2O. H2O. In acidic medium, 1 mole of the KMnO4 always gains 5 electrons, therefore 5. H2O to 1 mole always supplies 2 moles of electrons. 2 moles of the electrons. Therefore, in order to balance the reaction, first exchange the electrons. Therefore, 1 mole of KMnO4 requires 5 moles of electrons, whereas 1 mole of H2O2 supplies 2 moles of electrons. Just exchange the values here. 2 KMnO4 plus 5 H2O2 gives 2 Mn2 plus 5 H2O. Now, the meaning of this, after exchange of the values, we will get the another equation with the different stoichiometric coefficients. The meaning of this reaction is every 2 moles of the KMnO4 requires 5 moles of the H2O2. Now, we want the 1 mole of the KMnO4 requires how many moles of H2O2? According to this stoichiometry, 2 moles requires 5 moles. 1 mole requires how much? 2.5 moles. So, select the option where 2.5 moles of H2O2 is shown. In the third option, they have shown the 2.5 moles of H2O2. Therefore, third option is correct one. Next, question number 21. I2 plus S2O3 2 minus gives S4O6 2 minus plus I minus. So, now we want in this reaction, we want the equivalent weight of the iodine. First, we balance this reaction. Here 2 iodine atoms are participating. So, here 2 iodide ions. Next, here, see here, this is S4O6. This is a tetrathionate. Here 1 mole of the thiosulfate. Here we need 4 sulfur atoms. Now, we take to this. This is the balanced equation. In this balanced equation, now first identify the number of electrons released or gained by 1 mole of any reactant or product. Here in this reaction, we want the equivalent weight of the iodine. Therefore, you take 1 mole of the iodine. 1 mole of the iodine has 2 iodine atoms. Each iodine is in 0 oxidation state. Next, each iodine, it has gone to the product side. Here, the oxidation state of the each iodine is -1. Similarly, here -1. That means this iodine is gaining 1 electron. This iodine is gaining 1 electron. Therefore, 2 iodine atoms totally they are gaining 2 electrons. 2 iodine atoms means 1 mole or 1 molecule. 1 molecule is gaining 2 electrons. Therefore, valence factor of iodine is number of electrons exchanged. Number of electrons exchanged by number of molecules. Number of electrons exchanged by number of molecules. So, therefore, valence factor is 2. Therefore, gram equivalent weight of iodine, gram molecular weight by valence factor. gram molecular weight by valence factor. So now identify the option where gram molecular weight by valence factor 2 is shown. In the first option it is shown, therefore answer is 1. Next, the equivalent, next question number 22. Equivalent weight of the KiO3 in the given reaction. The reaction given is CrOH thrice, 2 moles are shown. Next 4OH minus plus KiO3 gives CrO4 2 minus plus 5H2O plus Ki. In this reaction we want the equivalent weight of the KiO3. So for that purpose, first identify the valence factor of this KiO3. In one molecule of KiO3, one iodine atom is present. The oxidation state of that iodine is +5. Next, on the product side, iodine was shown with the oxidation state -1. Therefore, this iodine, when it moves from reactants to the product side, this one mole of KiO3 has one iodine. That iodine is gaining how many electrons? 6 electrons. Therefore, valence factor of KiO3. Valence factor of the KiO3 is 6. Therefore, gram equivalent weight of the KiO3. Gram molecular weight by 6. So select the option where gram molecular weight by 6 is shown. Answer is 2. Next, question number 23. The product of oxidation of the I minus, the product of oxidation of I minus with MnO4 minus in alkaline medium. Here it is a theoretical question. You have to remember that whenever if KMnO4 react with the I minus, this I minus will be oxidized into IO3 minus, iodate. Therefore, the option is first option. So next. Change 24.